Jai Shri Gurudev. Good morning to everyone student. Welcome to chemistry class. In this session we are going to study the second chemical property of alkyl halide called elimination reactions. Under that the first one is dehydrohalogenation. Here the word itself indicates that dehydrohalogen means D means removal of hydrogen and halogen. The process of removal of hydrogen and halogen is called as dehydrohalogenation. In alkyl halide, the alkyl halide is treated with aqueous potassium hydroxide or sodium hydroxide. Removal of hydrogen and halogen takes place by the formation of alkene. This process we called as dehydrohalogenation. For example, observe, we are taking we are taking ethyl bromide or ethyl chloride. Example, take ethyl bromide, CH3, CH2, Br. This is ethyl bromide. This ethyl bromide is treated with alcoholic potassium hydroxide. Is a base. It gives alkene, that is CH2 double bond CH2 plus HBr. Here bromine and hydrogen from the beta carbon is eliminated. This is called as alpha carbon and this is beta carbon. Alpha carbon is nothing but the halogen which is directly attached to the carbon is called alpha carbon, and the beside carbon is called as beta carbon. After that there is a gamma carbon and delta carbon, like that. So here the hydrogen is removed from beta carbon. So observe, here there is 3 hydrogen. After 3, one hydrogen and bromine becomes HBr and the bond is formed between the carbon. Hence you get ketene. This is the one of the method to prepare alkenes from alkyl halide. Now observe, this can be explained simply like that. So this can be written like CH2 bond Br, here CH2 bond 1 hydrogen, right? So now this hydrogen and this Br, these two becomes HBr and this bond is removed here. So what you get? C double bond C, H2 bond H2 plus HBr. So this reaction takes place only in presence of what? Alcoholic potassium hydroxide or alcoholic sodium hydroxide. Without this base, the reaction do not carries or not takes place. This reaction is called as dehydrohalogenation. Now take one more example, that is CH3, CH2, CH2 bond Br. So this is called as propyl bromide. Because 1 to 3 carbon atoms. This is example 1, 2. So which is treated with either alcoholic potassium hydroxide or sodium hydroxide. Takes potassium hydroxide. Now this is alpha carbon, beta carbon and gamma carbon. If you write one more, that is delta carbon. Here the hydrogen takes place or removal from beta carbon. Here one hydrogen from here and this Br becomes eliminated. The bond is formed between CH and CH2. So what you get here? CH3, this one bond, one of the hydrogen removed, CH2 becomes CH double bond CH2 plus HBr. So what you get? 1, 2, 3, that is propene. One propene or we call simply propene. This is the elimination reaction. Now observe, these two are primary alkyl halide because the carbon having sp3 hybridization, primary alkyl halide. Means the halogen is directly attached to the primary carbon. If we take secondary alkyl halide, for example, observe, third example, take CH3 bond CH2 bond CH bond CH3 Br. So what its name? 1, 2, 3, 4. 2, that is 2 bromobutane. 2 bromobutane. So observe, in this case there is 2 beta hydrogens. This is alpha carbon because the halogen is directly attached to the carbon. This is called alpha carbon, beta carbon and gamma carbon. This is also called beta carbon, means there is 2 beta carbons. According to dehydrohalogenation, the hydrogen is removed from beta carbon only along with halogen. Due to the presence of 2 hydrogen, that is beta hydrogens, among these two, which one is most preferable to remove? That will be concluded by Sitjob's rule. Sitjob's rule. Based on that, we are solving this problem. Means this chemical equation, what type of alkyl halides we get. Now take the Sitjob's rule. Sitjob's rule says that internal alkenes are more stable than terminal alkenes. That is the statement of Sitjob's rule. That is, it states that internal alkenes are more stable than terminal alkenes. This is the statement of Sitjob's rule. So here is an internal alkene is nothing but the double bond is present inside of the alkene, and the terminal alkene is nothing but the double bond is present in terminal carbon atom between terminal and second carbon atom. That is called as internal alkenes. Terminal alkenes. Based on the Sitjob's rule, we are solving this problem. It means secondary alkyl halide or tertiary alkyl halide compounds. So here take these 2 bromobutene, CH3 bond CH bond CH CH2. Here one bromine and here hydrogen. This is called what? 2-bromobutane. So which is treated with aqueous, alcoholic potassium hydroxide, which is treated with aqueous alcoholic potassium hydroxide. The dehydrogenation takes place. One hydrogen from alpha carbon, beta carbon. This is alpha, beta, and gamma. So hydrogen from this carbon, this is CH3, not CH2, CH3, one of the hydrogen, and here bromine. These two get eliminated to get one compound. If one hydrogen from here and here are eliminated, you get another carbon. So another compound. Take 2 equivalents to balance chemical equation. Here also take 2 equivalents. Now observe. One bromine and hydrogen becomes. One bromine and hydrogen here becomes what you get? CH3 bond CH2 bond CH double bond CH2. See here, one hydrogen from here and bromine eliminated, you get this compound, right? Plus KBr or HBr you get. So similarly, the second compound is, if hydrogen from here, hydrogen eliminate hydrogen and bromine, you get double bond here. So what you get? CH3 bond CH double bond CH bond CH3. So you get this compound. So hydrogen Br becomes HBr and hydrogen becomes HBr. You get the 2 equivalents of HBr is eliminated. Okay. So among these two, which is most preferable, that decided by the Sitjob's rule. So this is called as terminal alkene because the double bond is present between terminal carbon and second carbon. Here observe, the double bond is present between 2 middle carbons, means 1, 2, 3, 2 and 3 carbon madhya irodrinda. This is internal alkene, this is terminal alkene, so that this is most preferable one according to Sitjob's rule. Andre ee product jaasti barutte, idu kadime barutte anta it Sitjob's rule. Its name is what? 1-butene, or simply called butene, that is 2-butene. So why it is stable? Because it forms geometrical isomers, geometrical isomerization or geometrical isomers, but this doesn't show geometrical isomerism. So that 2-butene is more stable than 1-butene, that is to Sitjob's rule. This is example importing Sitjob's rule for the purpose of examination for 2 marks. So the next chemical reaction is, the third chemical property is reaction with metals. Here the first one is reaction with magnesium metal, that is Mg. We also called as a preparation of Grignard reagent. Here Grignard is a scientist. He only prepared the Grignard reagent or MgX, Mg bond X, that is organomagnesium halide compound. Organomagnesium halide compounds. To prepare Grignard reagent, the alkyl halides is treated with metal magnesium in presence of dry ether solvent to get organomagnesium halide compound called Grignard reagent. The general reaction is observed. Alkyl halide, that is R bond X, is the general representation of alkyl halide. Important for the purpose of exam. Alkyl halide, which is treated with metal magnesium in presence of a dry ether solvent. Dry ether is a solvent. So observe the magnesium is added between alkyl group and halogenate Grignard reagent, that is R bond Mg bond X. This is called as general representation of Grignard reagent. Organomagnesium compound. Organomagnesium compound or organomagnesium halide compound halide is called as Grignard reagent. So Grignard reagent is defined as organomagnesium halide compounds is called as Grignard reagent. So this is general reaction. Now observe the example. Take methyl chloride or methyl bromide. Take methyl bromide CH3 bond Br. What is name? Methyl bromide. This methyl bromide is treated with metal magnesium in presence of a dry ether. The magnesium added between methyl and bromine group. So what you get? CH3 bond magnesium bond bromine. So what is name? Methyl magnesium bromide. That is alkyl magnesium bromide. So the alkyl magnesium halide and also called as organomagnesium halide. Methyl magnesium bromide is also called as what? Grignard reagent. So this is the method of preparation of Grignard reagent and the chemical property of alkyl halide, that is the reaction with halogen, reaction with magnesium. Then next one, reaction with sodium and also called as Woods reaction. So very important, Woods reaction. In this Woods reaction, alkyl halides is treated with sodium metal in presence of dry ether get higher alkanes. This whole process is called as Woods reaction. This is also called as reaction with sodium. Already we have studied reactions with magnesium, that is called preparation of Grignard reagent. Here reaction with sodium is called as Woods reaction. Most important. Now observe, according to Woods reaction, alkyl halides he is treated or heated with sodium metal in presence of dry ether, higher alkanes are formed. Higher alkanes is octane or higher alkanes are octanes. Sometimes we get more than one alkanes, so higher alkanes are octane. This is called what? Woods reaction. So observe the example, very important. So example, we are taking alkyl halide, the general reaction, take R bond X. This is general representation of alkyl halide plus treated with sodium metal. So take two alkyl halides of the same kind, X bond R. These are the two alkyl halides of same kind we are taking. Just I am writing reverse of this one. So here take two equivalent of sodium metal to balance the chemical reaction. these two reacts in presence of only the solvent dry ether, you get higher alkanes. Higher alkanes, that is see halogen, sodium and halogen, because 2NaX. So what you get here, right, like that. So hard bond hard and 2NaX is eliminated, that is hard bond hard plus 2NaX. So this is the general representation of Wood's reaction. You get hard bond hard, that is higher alkane. Higher alkane. So example, this is general example. Now take particular example. In place of what, take CH3 bond, in place of X take Cl, or take bromine, your wish, methyl chloride or chloromethane, which is reaction to equivalent of sodium chloride, place here take Cl bond CH3. Okay, so this chlorine and Na and this chlorine becomes what, 2NaCl, CH3 bond CH3 in place of what, dry ether. So what you get, CH3 bond CH3 plus 2NaCl. So what you get here, ethane. So when you get methane in a chemical reaction, that we call lower alkanes. If you get other than methane, we call higher alkanes or alkyne, like that. Okay. So this is the chemical reaction of Wood's reaction. So observe here, the special case in Wood's reaction is when we are taking two different alkyl halides. So observe here, I am writing here Har and here also Har. If I write here Har dash, these two are different to each other, so that you get Har and Har dash, right? So similarly, if you take two different alkyl halides, you get more than one product, means more than one alkane. That is given example here. So observe here, write methyl chloride CH3 bond Cl, methyl chloride plus Na sodium metal plus, here there is methyl chloride, right? In place of methyl take ethyl chloride, that is CH3, or take Cl bond CH2 bond CH3. What is name? Methyl chloride. Ethyl chloride. This reaction takes place only in presence of dry ether. So I write D, dry ether. So to balance this chemical reaction, take 3 equivalents. So later you know why I am taking 3 equivalents here, and here take 3 equivalents and here take 6 equivalents. Because observe, to react 1 and 2 equivalents of alkyl halide, we are taking 2 equivalents sodium. Similarly, 3 and 3 becomes 6 equivalents of alkyl halide to react 6 equivalent sodium it should be. So why we are taking 3 equivalents here? Why not 2 or why not 1? Because if 2 equivalents of methyl chloride react cell, you get ethane, like that. If 2 equivalents of ethyl chloride react cell, you get butane. If 1 equivalent from ethyl chloride and 1 equivalent from methyl chloride react together, you get propane. That is we are studying here. So observe, in the beginning 2 equivalents of methyl chloride react cell in presence of sodium and dry ether, like that. So what you get, ಅಂದ್ರೆ ಇಲ್ಲಿ ಎರಡು methyl groups react ಆಯ್ತು ಅನ್ಕೊಳ್ಳಿ, ಏನಾಗುತ್ತೆ ಈ ರೀತಿ react ಆದಾಗ methyl chloride and methyl chloride ಏನು ಬಂತು, ethane ಬಂತು, CH3 bond CH3 ಪ್ಲಸ್. ಅದೇ ರೀತಿ ಇದರಲ್ಲಿ ಎರಡು ರಿಯಾಕ್ಟ್ ಆಯಿತು, ಒಂದು CH3CH2 ಇನ್ನೊಂದು CH3 bond CH2 bond Cl. ಇವೆರಡು ರಿಯಾಕ್ಟ್ ಆಯಿತು ಅನ್ಕೊಳ್ಳಿ. ಇದರಲ್ಲಿ ಇರೋದೊಂದು, ಮೂರಲ್ಲಿ ಎರಡು ಸೆಲ್ಫ್ ಆಗಿ ರಿಯಾಕ್ಟ್ ಆಯಿತು ಅಂದ್ರೆ ಕ್ಲೋರಿನ್ ಹೈಡ್ರೋಜನ್ ಎಲಿಮಿನೇಟ್ ಆಯಿತು. ಅವಾಗ ಏನಾಯ್ತು, ಇವೆರಡು ಬಾಂಡ್ ಆಯಿತು. ಬಾಂಡ್ ಆದಾಗ ಏನಾಯ್ತು, ಬ್ಯೂಟೇನ್. CH3 bond CH2 bond CH2 bond CH3. So what you get, butane. If one ethyl group and one methyl group. ಒಂದು ethyl और methyl ಸೋಡಿಯಂ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಯಿತು ಅನ್ಕೊಳ್ಳಿ ಈ ತರ. ಅವಾಗ ಏನಾಯ್ತು CH3 bond CH2 bond CH3, right? So what is there? CH3 bond CH2 bond CH3. So you get 3 alkanes when we are taking 2 different alkyls. So how many sodiums are there? 6. So the byproduct is 6 sodium chloride compounds. So what is the name of these products? Finally, give the name of the resultant products. Its name is ethane. This is butane and propane. The byproduct is sodium chloride. So this is the Woods reaction. So important